Scientists recently witnessed something so immense, it didn't just challenge old theories, it blew a hole right through them. A collision was heard across the cosmos that is forcing us to rethink how black holes are even supposed to work. What we're about to explore isn't just about cosmic destruction. It's about a discovery that's painting a whole new picture of how the universe builds its most massive objects. On May 21, 2019, scientists using the LIGO and Virgo observatories caught something incredible. It wasn't a flash of light, but a ripple in the fabric of spacetime itself, a gravitational wave. For less than a tenth of a second, they heard the faint bang of two black holes spiraling into each other, an event they named GW1905-1. In that tiny instant, these two cosmic monsters released an astonishing amount of energy as they merged into one. But these weren't just any black holes. One was about 66 times the mass of our Sun, while the other was a staggering 85 times the Sun's mass. They slammed together to create a new, 142 solar mass black hole, making it one of the most massive mergers ever detected. This wasn't just a new record, it was a profound cosmic puzzle. Because according to everything we thought we knew, black holes that big shouldn't be able to form from a single star. To get why this is such a shock, we need to talk about something called the parent stability mass gap. Think of it as a forbidden zone for black holes. Our models of how stars live and die predict that the biggest stars, the ones that would form black holes, between roughly 65 and 120 times the Sun's mass, don't go quietly. Instead, they become so violently unstable that they detonate in an explosion that blows them to smithereens, leaving nothing behind. No black hole, no cosmic tombstone, just empty space. And yet, GW1905-1 presented scientists with an 85 solar mass black hole, sitting right in that forbidden's territory. It's like finding a fossil of an animal that our theories say could never have existed. It fundamentally challenged the model. So, how on earth is this possible? The leading theory is a process called hierarchical merging. The idea is that these giant black holes weren't born from single stars at all. Instead, they're second or maybe even third-generation black holes. It's a cosmic family tree. In some crowded corner of the universe, smaller black holes, the kind that form, normally smash together. Then, those newly formed, bigger black holes found each other and merged again, getting more massive with each collision. The black holes in GW1905-1 were also likely spinning and tumbling in their orbit, which could be another clue that they were the products of previous violent mergers. We aren't just looking at a single event, we're seeing the grand finale of a long, chaotic history written in the vibrations of spacetime. We are piecing together a wilder, more complex version of the universe, one gravitational wave at a time. If you're enjoying this journey into the cosmos and want to keep exploring these mind-bending mysteries, take a moment to subscribe. Now, the title of this video says a black hole collision broke the universe. While this event certainly broke our theories, it didn't literally shatter a galaxy. But don't get me wrong, black holes absolutely have that kind of power. The real galaxy shapers are the supermassive black holes behemoths with millions or billions of times the Sun's mass, hiding in the center of nearly every major galaxy, including our own Milky Way. When these giants feed, they are anything but neat. They're messy eaters. The gas and dust swirling around them form a blazing hot disk that can launch colossal jets of high-energy particles which travel for hundreds of thousands of light-years. These jets are like a cosmic thermostat for the whole galaxy. They can plow through enormous clouds of gas, either kicking off a frenzy of new star formation or heating the gas so much that it can't form stars at all. This process, known as feedback, is how a single supermassive black hole can control the destiny of its entire host galaxy. They are the true architects of the cosmos, and the energy involved is almost beyond belief. While a merger like GW1905-1 doesn't release more total energy than the stars, for the split second of the final collision, its peak power, its raw brightness in gravitational waves, can outshine all the starlight in the entire observable universe. So, the collision of two forbidden black holes didn't break the universe in a shower of cosmic shrapnel. It did something way more important. It shattered our neat and tidy picture of how the cosmos works. It showed us that the universe is far more creative and chaotic than our models ever predicted. Events like GW1905-1 prove there's a way for black holes to grow to incredible sizes, perhaps on their way to becoming the supermassive giants that command entire galaxies. We are just beginning to listen to the gravitational symphony of the cosmos, and it's already teaching us that some rules were made to be broken. What other cosmic rules do you think are waiting to be shattered?